Alright friends, in today's video we are going to wire the actual IC 4017. So this is the circuit diagram from the last video. Alright, so this is so now for don't worry about this Arduino Nano too much for now. So this is the actual integrated circuit. So this is let me turn it upside down so you can see this is CD4017BE. Alright, so we are going to wire this IC with this pin configuration. Alright, so now in this circuit we cannot see the VDD, that means plus 5 volts or plus voltage, and the ground voltage. So but in actual we have to wire the ground and plus. So in this IC, so this is the first pin. Alright, so this is the first pin. Alright, we count the pins usually from these left side. So from left we have 1 2 3 4 5 6 7 all together, always 8 and 8, and from here we have 9 10 11 12 13 14 15 16. Alright, so in this case 16th pin is the positive voltage. Alright, so this pin here is the positive voltage. I'm going to put a connector there. Alright, and after that I'm going to connect the other end of this pin to the 5 volt pin of this Arduino Nano. Alright, so we have the 5 volt pin right here. Alright, so this is the 5 volt pin. Alright, so now make sure we connect the correct one. So 5 volt in 5 volt pin is from the 1 2 3 4th pin. Alright, so this is the one. So let me connect it and we are good to go. Alright, so this is the 5 volt. Now 5 volt connected. The ground pin is in this IC the pin number 8. So the pin number 8 is right here. So let me turn this. So this is the pin number 8. Alright, so I'm going to connect this pin like this and connect this to the ground pin of the Arduino. Alright, so the ground pin is right here. So this is also where the resistors goes. Alright, ground pin. Now it's connected. Alright, now we have checked this diagram. We should connect the E, that means 13 pin, the pin number 13, and the pin number 15 into ground via a resistor. Alright, so let me get a 1k resistors from this resistor pack. Alright, so let me get two 1k resistors. Alright, so 1 and 2. Alright, now pin number 13 and 15 are going to be grounded. Alright, so let's get the pin number 13 here. Alright, so this is pin number 8. Alright, so this is 8 and this is 9 10 11 12 13. Alright, so I'm going to connect the 13 to the ground of this so I can connect it like this. So this is the ground pin of the Arduino. So the wire we connected to the yellow one. So I'm going to connect the same to the same pin. Now right now this is grounded. Okay, now we need another ground. So that is pin number. So this is pin number 15. So this is 13 and this is the 15, but I believe we have to use another method for this. Alright, So since this one is already grounded, so I'm going to use this pin. So this is 16, this is 15, and I'm going to directly connect this to the resistor like this. Alright, so this one also grounded via 1K resistor. Alright, okay, now we are left with the clock signal. Alright, so we are going to connect the clock, that means pin number 14. So this pin, so it's 15, 14, the in between pin. Alright, so 16, 15, 14, this pin. So as you can see, there's nothing connected here. That pin goes to the D13 of the Arduino Nano. Alright, so why D13? So in this Arduino Nano, I uploaded a simple program called Blink, and I adjusted its blinking rate to 500 milliseconds. So the default pin for that one is 13. Also the default LED pin is wired to 13 here. So with this LED turning on and off, this pin gets high and low. So let's go ahead and connect that pin also. Alright, so this is going to be D13. Alright, and this one is right here. Alright, as you can see, we get it externally, outer one. Alright, like this. Now you connected all the relevant and necessary pins, and including a plus and minuses. Alright, so just for test, so let's see. Now we should have pin number 3 and 2 high, and pin number 3 high initially, after that pin number 2. So let's first wire the first 3 LEDs like 3, 2 and 4. That means pin number 3, pin number 2 and pin number 4. Alright, so what I'm going to do is I connect one end of the LEDs to the IC by using connector wire. So let me pause the video. I will show you once I connected the LEDs. Alright friends, I need another breadboard, so that is because I found that this one does not have any room to fit the LEDs. So now I'm going to fit the LEDs. Let me put it away. So I'm going to put the LEDs in this board. So the plus is going to be like this, and the ground will be common. Alright, so let's connect LEDs one by one like this order. So there will be common ground, and pluses are going to be switched through the IC. Alright, so alright, I connected all the 10 LEDs. Now what we need to do is do the next connection from the IC itself. So let's do it next. Alright friends, now it's time to connect the main ground pin of this LED to this part. Alright, so I'm going to connect this wire, one end of this wire, into the other end of this pin. Alright, now the ground is connected. Okay, now so let's connect these 10 LEDs. Right, so I'm going to connect these 10 LEDs in order with these wires. Alright, so let me put this one away. Right, so now I connect this one and this one. And finally the brown. All right. So in here the order is follows like this. So we start from black one. First one is the black, so you can see the black line goes first. All right. So now let's see the first three, and then I pause the video and connect the rest, and let's try that one after the full connection. Alright, so in this diagram you can see the first one, that means the black wire should go to pin number 3 in this circuit. Alright, so here let's see, let me get my light over here. Alright, so let's get the black one to pin number 3. Alright, so let me get my black line here. Okay, here is the black one. As you can see, pin number is 3. So 1, 2, 3. Okay, so we can have the third. We can use the numbering also, because we match the pins with the breadboard numbers. So next one is, if we check closer, it's 1. So sorry, not 1. It's 2. So this is 2. Okay, so if you check from this side, you can see now it's connected to number 2. White is 2. Okay, next pin is number 4. That means the next white one, or light gray or whatever, that one goes to pin number 4, like this. Okay, now we connected the first 3 lines. Now we have this one needs to be connected. Alright, so let's see whether we can see the first 3 LEDs. So let's power up the circuit. Okay friends, now let's hook up the power to the circuit. So this is my 5 volt inline, so I'm going to plug this in, make sure the correct direction here, and after now I'm going to push this in. So as you can see, this pulse is this LED is turning on and off for the time period. Alright, so as you can see, the LEDs are moving here, so wait for another 10 counts. Right, this is first one, second one, third. Notice that these LEDs are counting to the rate of this clock. So every positive cycle this one changes. So let me go ahead and connect the rest of the LEDs and share the results. Alright friends, as you can see, I connected all the other LEDs. So now let's see how this one works. Alright. Alright, now starting from here, as you can see, for every positive clock cycle, the LEDs or rather counter gets increased. Alright, so notice I accidentally put 3 yellow LEDs at the end. Alright, so that's because I cannot find the color of the LED because everything is white. Alright, so now this is counting LED one by one. How do we create a progress bar with this? Alright, so how are we going to do it? So that is simple. Alright, so this IC only knows to count from 1 to 10. Alright, so with this clock cycle, alright, these clock cycles, this chip counts from 1 to 10. Alright, it counts one by one. So so how are we going to create a progress bar? The answer is simple. Alright, so like every other thing in the world, we are going to create a illusion. Alright, so like all the other things in the world, it's also
illusion. Here also we are going to create an illusion, right? So how are we going to create that illusion? We are going to provide high speed clock cycle
into this CD4017 chip. So with this high-speed clock, the LED is going to count from 1 to 10 at a higher speed. So so in our eyes we'll see it as these all LEDs are turned on at the same time. So let's go ahead and check that out. Alright friends, now we have increased the clock speed, so let's go ahead and plug this in. Right now I'm going to plug this. Alright, as you can see, now all the LEDs are turned on, but it's actually not every LED is turned on at the same time. The LEDs are counting from 1 to 10 at higher speed. So let me turn off the lights here. So as you can see, so this is the clock. So this LED, the second one, so this LED here is the clock LED. Also, as you can see, that also seen as it's always turned on, but that LED is also blinking at a higher rate that which our eyes cannot catch the blinking rate. So it seems that LED is also a light constantly lit. Alright, so same as these LEDs. So actually these LEDs are turning on and off quite fast, rather counting from 1 to 10 quite fast. If I set the reset here, as you can see, the one LED stopped. That means, so now that now I constantly press the reset here. So this is the place where the clock cycle stopped in when I press the reset. So if I release it start again. All right, so now when I press the reset, this is the place the clock stop generation stop. So if I release it, so one byte, so one clock pulse comes. So if I release that blink is the one cycle that it counts upward. So as you can see that, right? So this is kind of a game, you can see. So you cannot guess what's the LED bulb that you are going to stop when you click the reset. So you can see I got now 4th LED. So next time I press the reset again, so it's second LED. So it's kind of a random game. So now that's all for this video. So what we have done today is we increased the clock cycle to this CD4017 chip, and to make these LEDs looks like they are lighting all at once. All right, so in next video, now we can create the progress bar by limiting the number of LEDs with the reset. So for example, if I have 3, I get 1 2 3 clock cycles and reset, and 1 2 3 1 2 3 1 2 3 that refresh from there. So now we have 10 LEDs here, so we can create a progress bar from 1 to 10. So in next video, let's see how to create the progress bar with this CD4017 chip along with this Arduino, and we have to connect these reset pin, only the reset pin, alright, not the other pin. We have to connect the reset pin to one of the output pins in this Arduino. So the reset pin plays the major role here. It resets when we reach the actual value. Alright, so I hope you enjoyed this video, and thanks for watching. And don't forget to subscribe to my channel, that is Fun Text with Hashan. Also do not forget to click the bell icon so you will be notified when I upload any video. So thanks for watching, and thank you very much.